Ship A is sailing towards northeast with velocity v bar given by 30 I cap plus 50 j cap kilometers per hour, where I cap points east and j cap north. Ship B is at a distance of 80 kilometers east and 150 kilometers north of ship A and is sailing towards west at 10 kilometers per hour. A will be at a minimum distance from B in 4.2 hours, 2.6 hours, 3.2 hours and 2.2 hours. Okay. Now there are two ships. Again we are assuming that these ships are particles. Well, they are not, but for our understanding we are going to do that. So we have ship A. It is sailing towards northeast with velocity v bar equal to 30 I cap plus 50 j cap. So VA bar is equal to 30 I cap plus 50 j cap kilometers per hour. I east, j north. Okay, that's fine. Northeast. Okay. Ship B is at a distance of 80 kilometers east and 150 kilometers north of ship A and is sailing towards west at 10 kilometers per hour. Okay, ship B. That is VB bar. What is VB bar now? VB bar is towards west. Okay, towards west, so that will be negative 10 I cap plus 0 j cap. Did you understand this? Converting information into vectors? Huh. Now, what we can do is, we can assume that position of ship A at the given instant is origin. Okay? Suppose A is at origin at given instant. So B will be at, where will B be? 80 kilometers east and 150 kilometers north of ship A. Okay. Suppose A is here. B will be 80 kilometers east and 150 kilometers north. So B will be somewhere here, 80, 150. Do you get this?
Yes, sir.
Okay, yeah. So B is going to be at that position. What are the coordinates of that? 80 east, 150 north. So 80, 150. This is initial position. Okay, these are initial positions. Okay. We want the time where A will be at a minimum distance from B. So we would like to now express the distance between the ships A and B as a function of time, and then we would like to minimize it. Okay. So for that we have to integrate these to get the positions of A and B correct. So let us indicate the position of ship A by RA bar. It will be 30 T I cap plus 50 T J cap. Now we have not considered the constants of integration. I hope you understood why we did not, because it is initially or at the given instant it is at origin, and that is where our calculation begins. Okay. Can you people tell me how can we find the position of B bar? Well, of course we want to integrate VB bar. So it will be negative 10t. But make sure that initial conditions are met. So plus 80. I cap plus 0t. Okay. Well, its y position is going to remain constant, so let me not write it. The t part and okay, what 150 j cap. Is that clear?
Yes, sir.
Okay. Okay. Now, what will be AB bar? Because magnitude of AB bar will be distance. So can we find AB bar or directly find the magnitude squared? Because that will get rid of the root, right? AB bar squared. So how much will that be? B minus A. So it will be 80 minus 40t squared plus 150 minus 50t squared. Is that clear? 80 minus 40t, okay, that's fine. 150 minus 50 squared, okay. Now let us call this as our function d, suppose, or let's say, maybe I'll call it z, okay. Now we minimum distance, so let's try differentiating this. Now you realize that this function consists of two non-negative numbers because we are squaring, okay. So the value that we are finding after differentiating and applying the first and second derivative tests, it is going to be the minimum value, not maximum, okay, because there is no maximum value here. So dz by dt, okay, it will be 2 times 80 minus 40t into negative 40 plus 150 minus 50t into 2 into negative 50. Understood?
Yes, sir.
Divide by, okay, so divide by 200, I'll say divide by 200. So what will happen? 2 will get cancelled. Okay, first of all, okay, after equating this to 0, sorry, after equating this to 0, you can divide by 2 first and then divide by 100. So it will be 8 minus 40. 8 minus 4t plus, okay, wait, 8 minus 40 into negative 4, sorry, 8 minus 40 into negative 4 plus 15 minus 5t into negative 5 equal to 0. Okay. Dividing by 200. The two zeros will get rid of 0 in every term, plus zeros in 40 and 50, and 2 will get cancelled. Okay, so negative 32 plus 16t minus 75 plus 25t equal to 0. 16 plus 25, 41. 32 plus 75. So t will be 107 upon 41 hours. Okay, now what about the options? Okay, how much is 41 into 3? 123. So this is definitely less than that. So A and C are gone. Okay, so it is either B or D. Let us try D. Okay, let's multiply 41 by 22. Okay, so this is 90.2. 41 into 2.2, that is 90.2. Doesn't appear to be closer to that. Well, who knows? Just go for 41 into 26. 26 दोनों ले 26 चौक. Okay, 1066. Okay, so this looks close. Rather closer than 90.2. Okay, so what is the right option? Option B. Okay, let's just confirm it once. 107 by 41. 2.609. Okay, fine. So that's correct. 2.6 is the right answer. Okay, so how did we solve the problem? Okay, let's just go through it. Firstly, we noted the velocities. We brought in a coordinate system. Okay, we brought in coordinate systems because see, velocity is a free vector. We know that, right? It's not localized like position. Okay, so we brought positions. We had to assign something, so we assumed that A is at origin at the given instant, and that helped us in determining the original positions of the ships. And then we continued simplifying. And okay, one more thing that we did here was we basically considered square of the distance itself to be our function to be minimized. Automatically the square it will get minimized. Okay, and then chain rule of differentiation, simplification, and at the end a bit of division, a fair bit of division there. Okay, fine. So that is option question 6.